Good morning. My name is Bijan Tadayon, and I am here with Mr. Mohammad Ghayour, the president of the USPTO Intellectual Property Society of Iranian Americans. He is a supervisory patent examiner with the United States Patent and Trademark Office. I am also a former patent examiner and a member of National Intellectual Property Society of Iranian Americans. One of the shared goals of both of our new societies is to highlight the significant contributions of Iranian Americans in science, engineering, art, and intellectual properties. That's why we are very much thankful to you, Dr. Zadeh, especially for giving us this opportunity to have this discussion. You are the father of fuzzy logic. There are thousands of patents related to the fuzzy logic worldwide. There are 22 technical journals with the word fuzzy in the title alone. Fuzzy theory is being used in the wide variety of applications and industries. What led you to fuzzy logic and how was it conceived?
Well, before I answer your question, let me express to you my appreciation for your coming here all the way to Berkeley to interview me. I am pleased to have this opportunity to answer some questions you may ask. And I also want to tell you that I'm very impressed by the fact that you are have organized perhaps this intellectual property society for Iranian Americans. And I should like also to say that in giving talks in various places, particularly in cities in which there are many people from Iran, I'm always impressed. I'm always impressed by the fact that Iranians have achieved positions of responsibility in this country. And I think it's probably one of the most successful group of immigrants to come to the United States. Now, having said that, let me comment on the first question. Actually, it's not a simple question. It's not a simple question. So when I wrote my first paper on fuzzy sets in 1965, the reaction was mixed. Most of the people who commented were negative. Now, in part, it has to do with the word fuzzy. In English language, fuzzy is usually used in a pejorative sense. That means not in a good sense. So when I wrote my first paper on fuzzy sets, what I was looking for was a name for classes which do not have sharply defined boundaries. How to call them? I could not think of a name that was respectable and accurate. So I finally decided to use the word fuzzy, meaning unsharp. But I knew very well that it's the kind of word that will give some trouble. And indeed, it did. So there are many, many people who reacted unfavorably to anything connected with fuzzy set theory, fuzzy logic, because they thought this is not serious, really. This is some guy who doesn't know what he is talking about fuzzy sets. In fact, Senator Proxmire, at that time a senator from Wisconsin, he was looking at the budget of the National Science Foundation, and he found National Science Foundation is supporting a project on fuzzy sets. And he became very concerned about that. And he wrote a letter to National Science Foundation, why are you supporting such nonsense as fuzzy sets? And he was going to give me Golden Fleece Award. This award was given to people who were supported by the National Science Foundation and receiving taxpayer support for something that didn't make any sense. So I got a letter from National Science Foundation saying that he wants to give you this award. Please say something. So I finally persuaded Senator Proxmire not to give this award to me, but it was pretty close. This is just to give you an idea of what happens when you use a word that is not really a popular word. But this is not the only explanation. And what is very deep-seated in our culture is Aristotelian logic. A logic in everything is either true or false. There is multivariate logic, in which truth is a matter of degree. But fuzzy logic goes far beyond multivariate logic. So basically, fuzzy logic is a logic of classes which do not have sharply defined boundaries. That's really what fuzzy logic is. But because it's not in the spirit of classical logic, there are some people who were critical for that reason, not so much because of the word fuzzy, because they simply don't believe in partiality of truth. But what you describe does not apply to all countries. In English-speaking countries, the word fuzzy had a negative effect. But in other countries, this was not so. In Japan, fuzzy is one of the good words. In fact, fuzzy got sort of an award, medal, whatever, in Japan. So they use it on many, many products. They say fuzzy. If you buy a washing machine, fuzzy. If a microwave oven, fuzzy. Televisions are fuzzy, but not in the United States. They don't do it. So in any case, what happened then is that in 1966, a year after the publication of my paper, I received letters from Japan saying they saw the paper, they're very much interested in, and they would like to do some research 1 year later. And so in Japan, fuzzy logic became very popular. In other countries, in the Soviet Union, very popular. In China, very popular. In European countries, popular. So that what you describe applies mostly to the United States and some English-speaking countries, but not to other parts of the world. Not to other parts of the world. And so it is indeed very popular in many places, and one of the most important applications, visual applications. In Japan, subway system in the city of Sendai, which is not far from Fukushima. The subway system in the city of Sendai uses fuzzy logic. The work started in 1976, not long after my first paper. It went into operation, it took 10 years. In 1987, the system started functioning. Now, subway system is not a toy. It's not a toy. But the fact that in Japan, they decided to spend 10 years on the construction of this fuzzy logic subway system tells you that the reception was positive in Japan. And so today you would see many, many products use fuzzy logic. Digital cameras, almost all digital cameras use fuzzy logic. And automobile transmissions, all kinds of things. So in any case, what I wanted to say is that what you say is true, but it's a mixed picture. Some people were critical, some people were positive. Now, so far as I'm concerned, I did not react badly to criticism. I did not get myself into fights with people who said that fuzzy logic is nonsense. On the contrary, I said, you are my friend, I accept your criticism. Some people in my department here, right here in Berkeley, are very skeptical about physiology. Fine, we are friends, skeptical. And so in my life then, I have never been hesitant to be alone. And I have a photograph of myself at the University of Tehran in my room, and I have a sign above my desk saying Adin. Adin in Russian means alone. So I wanted to advertise that. At the University of Tehran, I also had opinions which were very different from the opinions of other people. Say, right. So I would say that my advice to people who find themselves in a situation where their views are unpopular, not to be scared, not to give in, not to surrender, but press their case.
Well, thank you very much. Likewise, thank you very much, Professor Zadeh, for the opportunity to have this discussion with you. In 1990s, you proposed computing with words and computational theory of perception. Would you please explain the underlying of computing with words and significance of that one over computing with measurements?
Well, I'll be pleased to do that. So if you look at science, you find that in science, numbers are respected, but words are not. So that if you open the paper and you see no equations, no mathematics, that most engineers, scientists will say that's no good. If there are many equations, they say it may be good. So there is this tradition of respect for numbers and lack of respect for words, deep-seated tradition. So back in 1973, I wrote a paper in which I introduced the concept of what I called linguistic variable. It's a variable whose values are words. And that is what humans use all the time. Talking about age, is it young, very young, not young, old, etc., etc., etc. About height, tall, very tall. Humans use words. And if you go back in history, they didn't use numbers so much. It's only in recent 100 years, 200 years that people began to use numbers. But today, when you listen to radio, watch TV, you find that people frequently use numbers. They say 25% are for this and 35% against it. Anyway, but what I said in that paper, 1973 paper, is that the use of words may have some advantages. You see. So this was counter to conventional wisdom. Conventional wisdom was words are not good, numbers are better. I said something different. I said that words can be very useful. And then I described how to use words, how to compute with words. So you can add small and large, you can multiply them, you can do all kinds of things with words. So this was my first paper in which I used words. So my 1990 paper is rooted in my 1973 paper. It came later. And so an idea which occurred to me at a later point was this, that humans use perceptions. You drive a car. Do you compute anything? No. Do you measure anything? No. You see? You go chef in a restaurant. Does chef in the restaurant measure anything? No. Doesn't need it. When you cook something, do you use measurement? No. I mean, once in a while, a few pinches of salt and so forth. So in much of what you do during the day, you really don't compute and you don't measure. And yet, you can do so much. Sports, basketball, people can do all kinds of wonderful things. No computation, no measurement. So AI, artificial intelligence, was measurement-based, logic-based. AI, incidentally, has never been very enthusiastic about fuzzy logic. AI has always been committed to classical Aristotelian logic. So then what I said is that the reason why AI has not been able to solve many problems is because AI used measurement-based theory, but to solve those problems, you need perception-based theory. AI and DARPA, very interested in automation of driving a car. After all these years, today we can construct cars which can don't need the driver in light traffic, but nothing that can work in city traffic. Nothing in New York, nothing in Tehran, nothing in Istanbul, nothing in Calcutta. People can do it. No measurements, no computations, no nothing, you see. So humans have certain abilities. And then I said, AI has made a mistake in putting all of its eggs into the basket of classical logic. We have to develop a capability to compute with perceptions. But how? My suggestion was take a perception, but describe it in a natural language. You see? I have a perception that most Swedes are tall. That's my perception. So I say most Swedes are tall. But then I ask question, okay, most Swedes are tall. What is the average height of Swedes? So I want to come up with an answer to that question, but I cannot do it using AI. I cannot use it using traditional methods. So I said, take most Swedes are tall and represent it in mathematical form using fuzzy logic. And you, once represented in fuzzy logic, then you can compute. This was the idea behind the computational theory of perception. I submitted an article to AI magazine, and some controversy, but eventually they published. And the title of my article was A New Direction in AI Toward a Computational Theory of Perception. They published it with the title A New Direction in AI. Now, but to understand this theory, you have to know something about natural languages and know something about fuzzy logic. The number of people who know both is not that large. So this theory had a sort of a slow thing, slow growth, because there are not so many people. However, if you use Google, and Google computational theory of perceptions, you'll find hundreds, perhaps thousands of results at this point. So there are many papers today in which they use this computational theory of perceptions for robotics, for this, for that, vision, speech recognition, many other things. But like many other things that I have done, understanding has been slow.
So based on what you said about artificial intelligence and computation based on perception, is there any interplay between a learning or adaptive artificial intelligence and computational theory of perception?
Yes. Well, what I can say is that there should be. But there is a large literature. This report on the impact of fuzzy logic shows there are 237 1,000 papers with fuzzy in title. I can read a few, you see. So if you ask me, is there an interplay? I don't do it myself, you see. I write only papers which are basic. So, but whether other people have done it or not, this is difficult to tell, except for Google. If you use Google, then I think you will find many papers doing that. Now, the concept of adaptive systems is one of the concepts that suggested fuzzy sets to me. I've written something. The concept of adaptation, I said, how do we define it? And then eventually I said, you have to use fuzzy logic for that. So to define what you mean by adaptive system, you have to use fuzzy logic. Now today, it is used very widely, actually, in so-called neurofuzzy systems. Neurosystems are good at adaptation and learning. Neurosystem. They combine the two. Out of combination comes neurofuzzy systems. And in Japan, in particular, there are many, many products that are neurofuzzy. So, for example, refrigerator, neurofuzzy. So, how is it used? Well, you use the refrigerator. You use freezer very infrequently. Other people use freezer frequently. The neurofuzzy system checks as to whether you use freezer frequently or infrequently and adjusts the controls, you see, depending on how you use the refrigerator. This would be a good example of adaptation. So I would say the best example of adaptation using fuzzy logic is neurofuzzy. There is also evolutionary. In evolutionary, genetic algorithm is also used there. Evolutionary also has to do with learning. And so there are many papers which are a mixture of evolutionary and fuzzy, so-called, and there are some, all three. Neuro-fuzzy genetic systems use all three. Fuzzy, neuro, evolutionary. So that, as I said earlier, there are many, many papers. I can look at only a small number, but there are fields in which adaptation plays an important role, and I'm not talking some particular papers, and in which the two of them or the three of them are used together. Now, for example, fuzzy logic transmission in Volkswagen, it checks how you use your transmission, you see? And depending on how you use your transmission, your driver, it adjusts to your thing. Let me give you another example of adaptation. Biometric measurements. This is an IBM patent. That's for user identification. You type. Now, people use different pauses between letters, you see? So fuzzy logic checks the pattern of spaces and so forth, and it identifies you. Are you the correct user or not, you see? So this is adaptation. This is an IBM pattern. So actually there are many systems in which learning is used. Now let me give you another example. As you asked me a question, now gave me a sort of refreshing memory.
Thank you very much.
Inverted pendulum. Inverted pendulum. Some Iranian, his name is Hamid Berenji, did that. So people can do that. They can balance. So his system learns it using fuzzy logic. You start with the pendulum. You don't program the pendulum. You raise it, it falls a few times, and then it begins to balance the pole. This is a good example of learning starting from zero, nothing. You see? That's a good example. Balancing an inverted pendulum. You may find that he has done a lot of work. He was working for NASA. Now he has a company of his own. And NASA used fuzzy logic in space and various other things. And he was the person who designed the systems for NASA. Hamid Berenji.
Professor Zadeh, you have made many other significant contributions in the scientific and engineering fields. As an example, what led you to the development of state-space theory of linear systems? Please tell us about the significance of that theory.
Well, after I received my PhD degree from Columbia, my master's degree from MIT, my field was systems analysis and information systems. That was my field. And I've written quite a few papers. My 1952 paper on Z-transform was during that period. And, so I was not very satisfied with traditional approaches to systems analysis. So I have written many papers in which I discussed various problems, one of which, for instance, was identification. The word identification was introduced in my 1956 paper. Not many people know. They use identification all over the place, system identification. But the word was used for the first time in my 1956 paper. Anyway, systems analysis. And so gradually then, yes, I was also influenced by some of the papers that Moore at Bell Labs wrote on finite state machines, in which he used automata theory and something. The concept of state was used in a certain way. So that gave me an idea to take that and apply it to, not to automata, but to linear systems and nonlinear systems. So that I began to write on that subject, and gradually it developed to a point where, together with Professor Ghayour, we wrote a book, 1963, that was 2 years before my 1965 paper, State-Space Approach. And in that book, what I did, the chapters, State-Space were written by me. I said that, you know what, we have this theory of finite states automata, we can take some of it and apply it to linear systems, different point of view. And so that I called state-space approach. And the state-space, prior to that, people used differential equations mostly to deal with systems. So that book had certain influence. In its time, it was popular, it was used in courses on control and so forth. But even there, I had some problems with initial understanding. Even though it was not fuzzy sets, but it took a while before people began to understand what is this state-space approach. Initially, they didn't.
You mentioned the Z-transform. A lot of people are wondering why the letter Z was used in the Z-transform.
Yes.
Any comment on that?
Yes. You know, this is a question that I am asked rather frequently. People assume that Z is connected to my name. No, it isn't. The reason why I use Z is because in the mathematical literature, there are some paper on difference equations by Levinson. In that paper, he used Z. Not the same sample data systems, but it's something that's related. He used Z. Because he used Z, I used Z. So that was because of the paper by Levinson, Z transform. But as I said earlier, many people assume that it's because of my name. I never did that. However, more recently, and for the first time, I wrote a paper called Z Numbers. Z in that paper is connected with my name. Z number. And the paper just appeared now, just a few weeks ago, in Information Sciences. And I think that that will have many applications. I'm very pleased that at my age, I could come up with something that is a new direction. So Z numbers will be used a lot. My fuzzy sets paper at 26,000 citations, Google citations. Usually a paper has 50, 60, 100. In Europe, to become a professor, your paper must have at least 50 citations. 50 citations compared to 26,000 citations. So it is the highest cited paper in information control. My paper is number 1. The second highest cited paper, 2,000 citations, from 26,000 to 2,000. So my paper on linguistic variable is highest cited paper in information sciences, number 1. My paper on possibility theory, highest cited paper in fuzzy sets and system. I had the same problem with possibility theory that I had with fuzzy sets. People did not accept it. But today, if you use Google, possibility theory, many, many papers. So my thick skin is thick. So if somebody tells me I'm stupid, say thank you very much for the compliment.
You have been educated both in Iran and in the United States. What advice would you have for aspiring Iranian students with ideas in the science and technology?
Yes, I got my bachelor's degree in electrical from the University of Tehran. And I must say that I received very good education, particularly the first 2 years. The second 2 years, which were sort of more concerned with electrical engineering, was less good. And of course, at that time, we had a whole course on armature wiring of motors. The whole course, not just 2 or 3 lectures. And a whole course on telephones, not today's telephones, but old-fashioned telephones, whole course. Anyway, so the last 2 years were like that, but the first 2 years, mathematics, chemistry, physics were very good, very good. And our professors were mostly graduates of French universities, École Polytechnique, École Normale. They were very smart. They were sent by the government to study in France, mostly France. They came back. There was discipline. The students were very enthusiastic. The head of the Danishgah Fani at that time was Riazi. Students were working at 10 o'clock in the evening in the library. He would come, and he would talk to students. It was that kind of a spirit. So it was wonderful kind of a spirit. And Danishgah Fani today perhaps is not like Danishgah Fani when I was a student. At that time, the entering class had 100 students. But it was difficult to get in. You see, they had passed competitive examination. At that time, it was difficult. And today, it's still very difficult. And at that time, you see, I came to the United States in 1944. Very few people came to the United States during the war. I was one of the few. And when I came to the United States, before coming, I applied for admission to MIT, and I was admitted. Why? Because there were not so many students at MIT. All the young people were in the army. They accepted me. They didn't know what is University of Tehran. They didn't know what is Iran. They didn't know what's the difference between Iran and Iraq, nothing. But they admitted me. They admitted me, but for me, MIT, after Danishkadeh Fani was very easy. I completed all the exams in half the time, you see? Because Danishkadeh Fani, it was very rigorous. In every course, you had 2 exams, written and oral. 2 exams, not just one. When professor was lecturing, at some point he said, hey, what is the answer to my question? Just like that. So students had to be prepared, you see? Or what do you have to say about this and that? It was this kind of a thing. So for me, MIT was easy, very easy, very easy. I did not complete my, I did not work toward a PhD degree because my parents came 46, they sold New York. I wanted to be with them, so I left MIT and I entered Columbia. But they wanted me to stay at MIT, but I did not want to stay there. But anyway, so today, of course, many students from Iran come to the United States, some other countries, and they are very good students, particularly from Sharif and some other universities. They are top-grade students, and many of them have become prominent in the academic world. So there are many people from Iran. They are in Canada, they're in American University. What a good example is Hamid Arabnia. He is chairing World Conference. It's going to be in Las Vegas. Largest conference in computer. Arabnia is the person who is organizing, starting it, and so forth. He is the man. Incidentally, he sent me an email message saying that there were 3,000 something submissions, papers submitted. 14% were related to physiologic at that conference. 40% related to physiology, which is a large number because that's the most important conference in this field. Anyway, so I think that today in the United States, many universities, they know that Iranian students are very good, very good. So some of the top students at MIT from Iran, in our department here, we have 3 or 4 people from Iran, very good, very good. So they have distinguished themselves, and so high reputation. And so when you say I am from Sharif, they know. Many students at USC, many students at UCLA, Los Angeles, and many students. But all over the United States and Canada. There are also students, of course, in other countries, in Germany and many other countries. So in any case, my advice is this, that do what you want to do and don't be scared if somebody criticizes or somebody disagrees with you. Don't hesitate to follow your own course. Don't hesitate to do that. And there is one wonderful thing about the United States, and that is that if you do something, you will be recognized. So who is your father, who is your mother, who are your relatives is not so important. So here you have achieved prominence, but you achieve prominence not because you are related to director of this, but because you have done it yourself. You see, done it yourself. So this is one of the wonderful things about the United States is that it is meritocracy. Do good work, you will be recognized. Whether you're Iranian or from Zimbabwe or whatever, it doesn't make a difference. And so do good work, you'll recognize. You'll recognize. The situation is a little bit more difficult now, right now, because the hiring situation in the academic world is not good. Our department, for next year, 0 new positions. 0 new positions. There are only a few or CS departments in the United States that are hiring many people. It's a difficult situation. And so you have to accept certain things. But I wanted to repeat what I said earlier, that Iranian students have very good reputation now in the United States academic world as well as industry. You go to Silicon Valley and you have many Iranian people who achieved distinction, who are presidents, vice president, chief executive officer, chief technical something, and doing very well. Many companies.
Dr. Lotfi Zadeh, we are thankful for your time today with us. I also want to thank 2 other friends with us, Mr. Shahryar Behnamian, a vice president of IPSIA, and Dr. Shahryar Khosrawani. In addition, we are thankful to Mr. Ben Hubbard and John Schneiker at the University of California, Berkeley Media Center for taping this session. Thank you very much.
Again, my deep appreciation.
Thanks.
And again, I want to repeat that I'm very impressed by what the Iranian community in the United States has achieved, and also to congratulate you on forming this society. My understanding is that intellectual property is interpreted in a broad sense, not in terms of patents, but the impact on art and literature and music and all kinds of intellectual activities. So I want to thank you.
Yeah, thanks.
Thank you very much, sir.